Okay guys, so now let's move to question 3.4, and the question reads as follows. Sketch velocity time graphs for the complete motions of stone A and stone B on the same set of axes. Label your graphs for stone A and stone B clearly. Show the following on the graphs. The time taken for stone A to reach its maximum height, the velocity with which stone B is thrown vertically downwards. So guys, for this question, the key here is that you are requested to sketch velocity versus time graph. Okay, so it's velocity versus time graph. So you are given your set of axes. So let's quickly solve this question, guys. It's one of those interesting questions that you should at all times score maximum marks. So this question, it actually indicates to the examiner or the marker that you fully understand this chapter of vertical projectile motion, because you're just basically representing everything that has been going on in a form of graph. So for you to be able to draw this velocity versus time graph, you need to have a full understanding of what was going on with those two stones. And again, your graph should be able to easily reflect to the situation. And again, you should be able to easily interpret your graph. So let's first start with our set of axes. So we're doing 3.4. And remember guys, because we've got stones moving up and the other one going down, and again you've got one other stone doing up and down, which is stone B. I hope you remember this stone went up and then it went down and it continued going down, and you had this one from the same level but it never went up, it started going down. So for that reason, it means in terms of velocity, which is your vertical axis, and you've got your horizontal axis, which is your time. So that means you are going to have your velocity on the positive side and also on the negative side. Remember guys, in physical sciences, the sign only represents the direction, but doesn't necessarily mean it represents the magnitude or the value in comparison to that of positive value. So I'll get to that point shortly, but for now let's just label our axis. So that means we've got, you can just indicate there to say this is velocity, and remember to write the sign. It's velocity in meters per second. I mean the units for velocity, and then now this is the axis for the time. You indicate the time is in seconds. So you use those units because throughout the questions, on all of the previous questions, you're referring to the velocity in meters per second, the time in seconds. So obviously this is the point where the velocity is 0, and from that point going up, that's where you have positive velocity. From that point going down, it means you've got negative velocity. So as I've indicated, the positive and the negative only refers to the sign. So if for this diagram we assume, let's say we assume up as positive and down as negative. You can still assume up to be negative and then down to be positive. But for this lesson, let's assume up to be positive and then down to be negative. So that means, for example, we can start with stone A. We can represent stone A on this graph. So obviously, in terms of time, guys, in terms of time, there's something which is very, very much important. So remember, the time. You should clearly indicate the time so that you can easily refer to this diagram when it's done. Remember, when stone A goes up, it takes 1.22 seconds. 1.22 seconds. I hope you remember from the previous calculations or the previous questions. Obviously, as it goes up, it takes 1.22 seconds. For it to return to the same level, it will take another 1.22 seconds. Then it makes 2.44 seconds. So from there to there, it's 1.22, another 1.22. That's why it's 2.44. Okay? And remember, guys, again, remember, when the time it's 0, that's when this object was projected vertically upwards. Just pay your full attention, because I'm also thinking and at the same time trying to make it simple, and again trying to make sense out of what we've gone through. So just try to easily explain. Remember, guys, initially when the time was 0, object A was projected vertically upwards at a speed of 12 meters per second. You remember? So because it was projected vertically upwards, that means we're going to start on the positive side of that axis. Why on the positive? Because the object was projected upwards, and we've just indicated that for object going upwards, this is the side on which we represent their velocity. For objects going downwards, we'll obviously represent their velocities on this side. So the question now is, what happens as this object A goes up? Does its velocity increase or decrease? The answer to that question is it decreases up until it gets to where its velocity is 0, which is its V final. And how long does it take for it to reach that point where its velocity is 0? It takes 1.22 seconds. We've already calculated that. So now we just represent it on the graph. So the question is, does it mean the graph starts from there where it's 12 meters per second, which is there? Does it go in that direction or in that direction? It cannot go in that direction, because if it goes in that direction, it seems as if as it goes up over time, its velocity increase. But it only makes sense when we say from that point, it goes straight down until it reaches its velocity of 0. Okay? And remember, guys, it reaches its velocity of 0 meters per second after 1.22 seconds. Okay? And then from there, from that point, what happens to that object? It goes down. It returns in the opposite direction. Can you see? So that's why from that point, it doesn't go in that direction, because if it goes in that direction, it's more like As it goes up, its velocity decreases until it gets to 0 meters per second. Then what happens? If we go in that direction, it's more like as soon as it reaches its maximum height where its velocity is 0, it starts to gain its velocity in the same direction, of which it's not what we've gone through when we're doing those calculations, and also based on the given information. They said as soon as it reaches its maximum height, it goes in the opposite direction, goes down. That's why we continue in that direction. So it continues in that direction, obviously on the negative side of the velocity, as we indicated that downwards it's negative. I assume so far you understand what's going on, guys. So up to that point, remember guys, what happens at that point? So at this point, this is that point where it is now on the same level where it was initially projected vertically upwards. So as soon as it gets to that level, does it stop there or it continues going down? Obviously guys, it will continue going down because this is just the point where it was thrown or projected vertically upwards. It reaches its maximum height, it goes down, it will obviously pass that level heading towards the ground. Can you see? That's why we can now just extend that line. Okay, we extend it because as soon as it reaches that level, it continues going down. So we can just end that line somewhere there. We can't specify the time because we haven't calculated how long it takes for that object to travel from there up to the ground. Okay, so that means this is our stone A, right? So now I'm just going to erase all of this information, then we'll move to stone B. So now let's try to make sense of stone B. So what happens with stone B, guys? Obviously stone B, from that level, it is thrown vertically downwards. Okay, it's thrown vertically downwards at what initial velocity? Its initial velocity was 5.98 meters per second. So what I was saying, guys, initially I've indicated that it's negative 5.98, but then it doesn't necessarily mean that negative 5.98 because it's negative, then we say it's smaller when we compare it to the velocities maybe on the positive side of that axis. That negative, it only indicates that it's actually moving at that speed but downwards. That's why I'm saying negative and positive, they are only referring to the direction. So now that we know that at time 0, or initially from the start, obviously from the start the time is 0. So from the start, object B went down at 5.9 meters per second, right? So as it goes down, guys, as it goes down, what happens to its velocity? Does it decrease or does it increase? And again, in which direction? So you will obviously notice that from that point, its velocity increases in the same direction, which is downwards. So we cannot go in that direction, because when we go in that direction, it's more like it was going upwards, whereas we know it was going downwards, right? So that means we draw a line which is parallel to that line. So it may not be 100% parallel, but because I've mentioned that it should be a parallel line, I know you're going to use a ruler to draw that line, because the thing is, I don't want to use a ruler so that everything it's clean. So remember guys, at that time, that's where this object hits the ground. I hope you remember. So that's why that line, it should end right there. It should end right there. Why? Because this object takes 2.44 seconds to hit the ground. So as soon as it hits the ground, that's the end of its journey. So now we can just label to say this is our object or our stone B. Okay, so I think this is how we've answered a question, guys. Let me just quickly check from the question paper if we have answered everything before we start marking this question, but I think everything is provided. So let's check. So they said sketch velocity time graph. We do have velocity versus time graph drawn for the complete motion of stone A and B on the same set of axes. Label your graphs for stone A and B clearly. We did that. This is A, this is B. We have velocity versus time graph, and this shows a complete motion of both stones. So they say show the following on the graph. The time taken for stone A to reach its maximum height. We have indicated that for this stone A to reach its maximum height, this is when it reaches its maximum height, right? And again, they say show the velocity with which stone B is thrown downwards. We have indicated that it was thrown downwards at 5.9 meters per second. It continues going down until it hits the ground, and this is the time it took for it to hit the ground. So now I think we've answered everything, so that's why I would say we deserve full marks. Okay, so we have shown the time, not necessarily the time, but the velocity at which stone B is thrown downwards, and again they will give us a mark for indicating that the journey for stone A, and again for showing the time when it reaches its maximum height, and again they will obviously give us a mark for showing a stone B, the journey for stone B. So this is how you score 4 marks. Let me just indicate there that this question was allocated 4 marks. So guys, this is how you score your full 4 marks. So I think, I'm not sure if we should try a different question or if we should continue with the same chapter but dealing with a different question paper. But I think this lesson was worth your time and you fully understood exactly what was going on. So thanks very much for joining. My name is Desmond and I'm out.